Thank you very much. First, I would like to thank you, Annie, for inviting me to give this presentation on apparent sea level rise and earthquakes. And particularly, I want to show a case where this apparent sea level rise impacted people and was interpreted as a sea height change, where in fact the ground motion had a very significant contribution. So it's what I call the Torres example. There, in a plantation was slowly dying, and this was interpreted as a climate change effect. And also, people from a village, Tegue village, had to move because of regular inundation of the village. And these people were designated at a United Nations Environment Program conference as possibly the world's first community to be formally moved out of harm's way because of climate change. So it was a very serious statement. And I want to present you the case where, first, where are the Torres Islands? It's a small island here in the northern part of the Vanuatu archipelago. And Vanuatu is located in the southwest Pacific, where the Australian plate here is diving underneath the border of the Pacific plate at a mean rate of about 12 centimeters per year. It's a very active tectonic boundary. You can see here all the earthquakes recorded since 1973 on the global network. Full of earthquakes, you don't even see the islands. And here's a zoom on the Torres, where in the recent past, you had many above 7 earthquakes magnitude. So in this context, we can wonder if the coastal flooding observed in the Torres is really a climate-related sea level rise, a tectonically induced subsidence, or a combination of both effects. Because as we say, the apparent sea level rise for the people who live there could be the same with both processes. So let's first have a look on sea surface height variation seen from satellite. So completely, it's not relative, it's the absolute sea level rise. Torres Islands are located here, and you can indeed see that they are experiencing a well above average trend in sea level rise. It's around, it's above 7 millimeters per year. If you look at the time series, these variations are not linear, but they involve seasonal signal and a major role of these El Niño-La Niña oscillations. On the long term, the Torres Islands are rising by 1 millimeter per year on the average. This has been shown by Taylor et al. Using coral platform. So Professor Barr, here it's using coral also, but in the opposite way. You can see the uplifted tables up there. So we know that on the long term, the island is rising. However, on the shorter term, these rising processes are superimposed with a shorter term seismic cycle, where islands may be uplifted and then subsiding, uplifting and then subsiding. And this is typical in subduction zone. I will show you a little bit the process. Here on a cartoon, you can see that when a plate is diving, it's actually dragging down the upper plate when the subduction is locked. And so the island seems to gradually sink, or the apparent sea level is rising, until an earthquake, when the island is when the strain accumulation release, the coast is suddenly rising, and the sea level seems to drop. And this is a finite model, and this can happen in a cycle way. So in the Torres Island, thanks to one single point installed in 97 after a big earthquake, we were able to actually quantify this interseismic subsidence, which is in the order of 1 centimeter per year, and then another series of earthquakes of magnitude 7.8, 7.6, and 7.2 happened, and giving a coseismic jump of 20 centimeters. Now, if you superimpose this ground motion to the absolute sea level rise, this is the apparent sea level change observed by the islanders, and it's in the amount of over 2 centimeters per year. And finally, the total apparent sea level for this islander also includes coseismic jumps and can reach a total amount in the order of a meter. So, of course, it does impact population very seriously. But in fact, so we've shown that the dominant factor here in this particular case is not the global warming, but rather the ground motion. But is it a problem really to misidentify the cause of the rising as long as the village moved? Whether it's climate change money or seismic money, it doesn't really matter. I would argue that yes, probably it matters because they may have moved to a safer place with a proper investigation and would not be as exposed to future land motion or tsunami here. So it may be important to understand really the cause of the apparent sea level change. So this was for the case of the Torres, but I'd like to present you a few other examples here where coastal apparent sea level change have been evident at the time of the Chile Mole earthquake in 2010. For the same event, you can have at the coast subsidence here, significant subsidence, where you can see grass flats that were green before and now are dying, and that's in the north. And further south, you can see significant uplift. This is tables cut by waves before, and now they are completely exposed. So this is the coseismic motion, and it matches with GPS observation, but you don't always have GPS observation on the coast. And this work by Vini et al. You can see that close to the coast, it's mainly uplift, and further inland, it's further away from the trench, I should say, it's mainly subsidence. In fact, this is exactly opposite to what Rueg et al. Earlier have evidence in the interseismic period before the earthquake, where you had subsidence on the coast and uplift further away from the trench. This makes me go back to the previous cartoon where when you have a locked zone, in between earthquakes, you can see that it's subsiding close to the coast and uplifting behind, and it's exactly the reverse at the time of an earthquake as observed here. So apparent sea level change give insight on the locked zone geometry, and they can contribute to the seismic hazard assessment, and this has a real relationship with impact of sea level because it needs to be taken into account when in terms of coastal management. However, seismic cycles are a long process, and it would be nice to have a record, longer time record, and this is once again provided by apparent sea level changes, but recorded in corals, because the corals, some corals are very limited to, their growth is limited by the lower sea level height, and so when it's not moving, you have the coral like this, but then if the sea level drops, the coral is exposed, and then stop growing, die. When the sea level rise again, the coral can grow again upwards. And when you find micro atolls like this, you can actually record the history of past sea level. It can be used for climate studies, but it can also be used for earthquake studies and give insight on these processes. C et al. Have used this micro atoll and the apparent sea level changes to actually map the seismic cycle through the past, and this is also very important for earthquake assessments. And these techniques of actually using the apparent sea level rise can be in turn used for earthquake. So I won't go into details here because I think some people are could better answer the questions, but as sea level measurements accuracy increases, we may need to consider second-order contribution of earthquake to actually apparent sea level changes. Melini et al. Have evaluated that the global contribution of earthquakes to the long-term changes could be in the order of a tenth of a millimeter per year, and also using Gray's gravity data, and Pane et al. And other teams have shown that variation are induced by very large earthquakes, and that they can be detected in this gravity data. And you can see here that it's around a centimeter geoid variation, and geoid variation mapped directly into sea level, global level. So this brings me to my concluding remarks. Is a bit summary that by inducing static deformation of the crust earth, earthquakes do contribute to relative or apparent sea level change, and the contribution of slow interseismic deformation may be significant, but it is hard to identify in the apparent sea level change without independent data. And this led to the misinterpretation of the Torres climatic refugees. And relative sea level changes recorded by natural markers such as coral provide earthquake cycle records and may be key in seismic hazard assessment, which is also key in coastal management and sea level assessment. And note that the entire Pacific Ocean is bordered by active plate boundaries, so tide gauge must be corrected for ground motion to get the proper global sea level rise estimates, as shown by, in particular, by Guy Voppelman just before. And also, relative sea level change may be used for geophysical purpose and give us insights. Okay, thank you.